Hello everybody, this is Johnny. Let's make a game together. For this game you'll need some paper, something to write with, dice, 2 sets of 3 dice, playing pieces, colored pencils, something else. Oh, you'll need a bear. Let's make our game. Let's start by making some rectangles here at the bottom. So start down here and draw long rectangles like this. Make 2 of them, one on either side. Straight lines if you can make them. Try to make another box inside. This will make it more interesting. Box inside a box on both of them. All the way across. And then in these boxes, a couple more lines. Let's make lines going all the way across, horizontal line for each of these. And then 2 here, and 2 here, 2 here, and 2 here. But you'll notice that there are 10 spaces in each of these now. 10 over here and 10 over here. This is important because this is our FRACTONIUM. Be very important to the game. Let's do some more drawing. Over here, let's make a rectangle. Maybe like this. That's looking good. Over here, similar, but let's make some interesting corners on this rectangle. Looking good. Over here, let's do this. And maybe this now. And maybe a little bit of this. And down here, a box, maybe another box, and some connectors. And over here, a box, another box. And maybe some connection. Over here, let's do something like that. Maybe just a little different. Like that. And down here, a curve, maybe 2 curves. Over here, a curve and another curve. And some lines going down. That. Over here, let's go ahead and make this. And maybe like that. And over here, like that. And over here. Middle part 2. And the bottom part here. What are we missing? We're missing something here. Oh, yeah. Have to do this, don't we? Over here. How about that? And how about this? Something like that. And on this side, and okay, those are looking good. Need something more though. We need to have for this game a very strong bar in the middle for each of these. This bar is going to matter a whole lot. The reason that bar matters is because this game is called FRACTOBOTS. I'm going to give each of these a little color. Start over here. We need to add one more thing. Let's add this. 1/2, 1 whole, greatest, and least. Let's play the game. We'll need to have a marker that we place by these in the middle. The first one's going to be a 1/2. Blue's going to have the blue dice, red will have the red dice, and we'll use the counters as we need. In this first round, each player is trying to get closest to 1/2, making fractions with the dice. Let's see how it works. Blue rolls, and red rolls. Now you see that bar in the middle? That's our fraction bar. Now we're trying to get close to a 1/2. Now, blue player can use 2 dice to make a 1/2, or all 3 dice to make a 1/2. Could make 4/6, 4 on the top and 6 over here. And blue looks at the dice and says, you know, I could put 2 on the top and 4 underneath. That looks like a good 1/2. What is red going to do? Red could make 1/3. Red could make 3/3. That's too much, isn't it? Red could also make 1/2, which is also a 1/2. So in this round, they battle it out and no player gets a reward for this. We go to round 2. Now we're trying to see who gets closest to 1 whole. Blue rolls and red rolls. Remember, they can use any number of dice here. Blue looks at this and says, you know, I've got 5/5. That's pretty close to a whole. Red looks at the numbers and says, the closest I can get to a whole is 5/6. That's okay, but it's not as good as 5/5. In this round, blue wins FRACTONIUM. Now we move to greatest fraction. Blue rolls and red rolls. Blue can make a number of really large numbers here. Blue could make 3/3, which is equal to a whole, or could make 6/3. 6/3 is equal to 2. That's a pretty good large number. What can red do? Well, red could make 5/4. That's more than a whole. But red could also make 9/1. 9/1 is equal to 9 altogether, which is a really big number. So red is going to win this round because 9 is larger than 2. Red will get a piece of FRACTONIUM for this one. Now we're going to least. Blue rolls, red rolls. What does blue have? Blue could make 1/7. That's a pretty small number. Red could make 3/4, could also make 3/10, which is smaller. 3/10 or 1/7. If you're not quite sure, look at this. This will be at the very, very end of the video as well, so you can find it there. So if we're looking at our numbers, 1/7 is over here, and the other number, 3/10, is over here. 1/7 is less than 3/10. Blue is going to get some FRACTONIUM. Let's continue. Let's go back up to a 1/2. Both players are going to roll. Blue rolls first, red rolls. Each of them is trying to make a 1/2 this time again. So let's see what we have here. I could see blue can make a quarter. That's okay, but not as good as 1/3. 1/3 is much closer to a half. So blue is going to stick with 1/3. Red, what can red do? Well, red can do 3/5. Red can also do 3/8. Which one's better? And you can use the chart if you need to at the end of the video. I'm looking here. Here's 3/5. Here's a half. Here is 3/8, and here's a half. We can see that 3/5 is better than 3/8. And we can see that 1/3 is over here. Not as good as 3/5. So red decides to play 3/5, which is closer to a half, and gets another piece of fractonium. Now we move down to one hole. Blue rolls, red rolls. Which one's going to have a better hole number? Blue looks at the possibilities and decides that 4/6 is probably the closest to a hole. That's possible with those dice. Red looks and says, you know what, I think I can do better. I could do 5/6. 4/6 isn't as close to a hole as 5/6. So red's going to take another piece of fractonium. We go down to greatest now. Blue rolls, red rolls. Blue likes the roll that's been made. Blue can put 10/1, which is equal to 10 holes. That's a really big number. Red can make 10/2, which is equal to 5, but not as much as blue has with 10. So blue is going to win the greatest and get some fractonium. Let's go down to least now. Blue can make 4/9. Red can make 4/6. Can you figure out which one's lesser? We look at our chart. We look for 4/9. Here are the 9ths. Here's 4/9. Where's 2/6? 2/6 is over here. So 2/6 is lesser than 4/9. So red wins more fractonium. Keep taking turns going down this list until one player has gotten 10 pieces of fractonium and is the winner. If you're not so sure about the fractions, you might look at the fraction list I put at the end of this video. I also have more video at the end that tells you how to compare the fractions for yourself, and that might be worthwhile too. For this game, you need some paper, something to write with, maybe something to color with, dice, some fractonium, a marker, and something else. What else do you need for this game? Oh, you need a bear. Do enjoy this game. So what we want to do today is we want to compare fractions. Let's think about 3/8 and 2/5. So this is what 3/8 looks like. 1/8, 2/8, 3/8. Let's take a look at 2/5. 1/5, 2/5. They look about the same, but they're not the same things. These are 8ths, and these are 5ths, apples and oranges. We need some way to compare them so they're like each other. So we want to use like fractions. Right now, everything over here is in 8 pieces, and everything over here is in 5 pieces. Can we make them the same number of pieces so we can compare them the right way? Let's try that. So over here where we have 8ths, let's divide it into 5ths as well. So I'm adding 5 spaces going down. You can see there's 1, 2, 3, 4, and 5. Over here with the 5ths, let's do the other side. Let's make this into 8ths. So let's divide this into 8 pieces. 2. Add some more there. Now that there we have 4 pieces. Let's divide each of these. I want you to think about how many pieces are in each of these now. 1, 2, 3, 4, 5, 6, 7, and 8. Under the eighths we have 8 across the top and 5 across the side. And 8 by 5 gives us 40 spaces. We have 40 spaces in this box now. How about in the other one? We have 5 across the top and 8 across the side. 5 by 8 also gives us 40. Now we have the same number of spaces, same area for each one of the pieces. Now we can make a comparison. Over here we have 40 spaces, and how many are colored in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them. So 15 40ths is the same as 3/8. And what do we have on the other side here? Well, we know we have 40 spaces now. How many are colored in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2/5 is the same as 16 40ths. We can compare 15 40ths to 16 40ths to know more about these fractions. Let's think of this another way. What we want to make are like fractions. So let's try this. Let's set out 3/8 over here, 2/5 over here. We're going to multiply this by the number 1, fraction form in a moment. We know that when we multiply something by 1, it stays the same. Same with 2/5. We're going to multiply this also by the number 1 in just a moment, so that we end up with something equivalent to 2/5, and on top something equivalent to 3/8. But here's what we're going to do. We're going to make this a very special one. And we're going to be using the denominator of 2/5. Let's go ahead and make this 5/5. We know that 5/5 equals 1. And below, multiplying 2/5 by the denominator of 3/8, we'll make 8/8 here. Let's see what we get here. 3 times 5 is 15. 8 times 5 is 40. And down below, 2 times 8 is 16, and 5 times 8 is 40. Again, we have like denominators, which is what we want to have. Now we can compare 15 40ths to 16 40ths. And when we do that, we're really comparing 3/8 to 2/5. Let's look at another kind of comparison. Which one is greater? We know 3/8 is the same as 15 40ths. And we know 2/5 is the same as 16 40ths. And we know that 16 40ths is more than 15 40ths. So we can say that 2/5 is greater than 3/8. Which one is lesser? Again, 15 40ths and 16 40ths. 15 40ths is less than 16 40ths. So we can say that 3/8 is less than 2/5. Let's try something more. We could ask which one is closest to one whole. Let's use a number line to help us. Put one whole here. Could be anywhere. And let's put what we know about our fractions above on this line. We know that 3/8 is the same thing as 15 40ths, not quite a half. We also know that 2/5 is equal to 16 40ths. Which one of these two is closest to 1/2. 16/40 is closer, so we can say that 2/5 is closer to 1/2. Let's do one more. Which of the two fractions is closest to 1/2? Let's use a number line again. We'll put out 1/2 maybe about here. Again, 3/8 is the same as 15/40. 2/5 is the same as 16/40. Which of these two is closest to 1/2? 16/40 is this far from 1/2, and 15/40 is this far. Now we know that 16/40 is closer, so we can say that 2/5 is closer You can make other comparisons with other fractions as well. As long as you find like denominators, that will always help. And don't forget to use number lines too, so you can see the comparisons as well. Hope this has been helpful.